Hi, I'm Dr. Scott Tarnavieski, and I'd like to thank all of you for attending this month's Kent Miller and Quinton Reeves honorary lecture series. If you don't know, Kent Miller and Quinton were longtime employees of Weatherford College, instructors in political science. They retired just a few years ago. And so we thought we'd honor them by naming this lecture series after them. Now today, our guest speaker is going to be Professor of Geology Jim Mellott. Professor Mellott has been teaching at Weatherford College since the year 2000.
Full-time.
He has a Bachelor's of Science in Geology from Capital University, which is in Columbus, Ohio. A Master's of Science in Geology from Washington State University. Additionally, he has taken quite a bit of graduate coursework in both geography, climatology, and meteorology. And he will be discussing a hot discussion about climate change in a sense, right?
Climate and climate change.
All right, thank you.
Thank you, everybody, for coming. Climate cycle, past and future. Couple points. It's easier to fool people than to convince them they've been fooled. That's the biggest. That's true of us all our life. We tend to focus that more individually, but when we get away from individual situations, we tend to get scammed. Climate, two aspects of it, science and politics. We will talk about the science, the whole truth and nothing but the truth. Politics is gender-driven. We'll get to that later. We're going to talk about climate. We don't have a climate today. We don't know where we are. We have weather, but we know what's in past climate or the future climate. Because climate is a 300 to 100 to 300 year, oops, there it is, 100 to 300 year average. We haven't had 300 years, none of us lived that long. The other problem is knowledge. We've always had weather for 450 billion years. That's their first day on Earth. But whether we have, what we talk about weather today is much different. Because it only started with the knowledge of weather, only started 100 years ago with the advent of air flight. Because you had to know what's the weather in the airport I'm taking off, what's the weather before I get to the other airport, what's the weather at the other airport, the forecasting. And so we started generating, and that knowledge came with, right after, as I said, from the 1930s on, with the advent of, first of all, we didn't know about the jet streams until World War II. And then we started to pick up the modern technology to get the balloon data up through the atmosphere, and the computers to put it together, and the radar, and the satellites. So we're learning much more. And then climate, again, climate is historical. We'll talk about that later on, how it goes up and down. And the proxy data is mostly proxy data, because we haven't had that, as I said, only 100 years of real data. This is what we know about climate, unfortunately. What we know about climate is little blue sliver. What we don't know is the red sliver. And the whole rest of the pie is what we don't know. And we're discovering some of that because of our advance in technology right now. Some big things. We'll talk about some of that later on. This is a generalized diagram of what we know about weather and climate today, all the factors. But each of these factors has many attributes. And each of the attributes vary over different time frames. And with temperature and pressure and distance, vertical and horizontal distance. And the effect of the other factors on them. So this is not a static this is a static diagram from your standpoint, but in real life, it's just vibrating all the time. It's always changing. What we have in weather today, right now, this instant, a minute later is different. You know that the temperature goes up during the day. Those are the one factor. So what we know about, what's the truth we know about CO2 from a scientific standpoint? First of all, you can't measure the effect of CO2 absorption of heat from the Earth because it's in the gas in the atmosphere. So you have to isolate it. You have to take it into a lab and isolate it and test it. And what you do, you find out it's a logarithmic curve. The more CO2, the less heat's absorbed. That's that simple. Today, we get about 4 degrees. You double that, you're out to 4.4. I like CO2 in that respect. So it's not, and all it's doing is really like water vapor, is slowing down, because once that energy goes out and activates the CO2 molecule, it's there for just a microsecond and gone until a flashlight goes out to space. It's part of the albedo, and we need it, don't get me wrong. We need the albedo, but most of it's water, 200 times more water than CO2. This is the longest recorded temperature that we have. Central England, 350 years, of course, of recorded temperature. Now, interesting enough, that little green line is the average. For 350 years, we've increased temperature 1.5 degrees. But it's been a steady. But if you look at the maximums and the minimums, it's about 4 degrees. And guess what? We haven't burned up. Even though some people say at 4 degrees we're doing it. The black line, now as I said, that's a steady one. The black line here is CO2. We couldn't measure CO2 until late 1800s. That's this little line here. And it is a point measure, not a continuous measurement. You have to bring it to the lab and test it. And sure enough, it's increased and gone up. But what you see, and everybody shows you a picture of, is this red box with a little different scale. And sure enough, the temperature's going up, CO2's going up. Oh my God, CO2's driving it. But they don't show this part down here. With the CO2 down here rising up, temperature's not changing. This is the so-called global pause that we've talked about for the last 19 years. Temperature's basically stayed steady. That's why they call it a pause. There's been high points and low points, but the average has been 0. No increase in temperature. But the CO2's gone up. No increase in temperature. And this one is, I love this one, because it's, as Mark Twain says, very simply, you can fool the people. Statistics don't lie, but statisticians do. So do people that do graphs. This is a blow-up of the 300-year of the Vostok-Ive curve that Gore shows you in the Inconvenient Truth. And sure enough, in that picture, see, the temperature goes up, the CO2 goes up, boom, boom, boom. But when you blow it out and look at the detail, the temperature goes up, and 800 years later, the CO2 goes up. And temperature drives CO2. Now, I'm sorry, ladies and gentlemen, you all know this. You pull that nice effervescent beverage out of the refrigerator, pop the lid, and if you walk away and come back an hour later, is it still effervescent? No, the CO2 is out of it. It's warmed up. Warm fluid drives off gas. Every chemist and physicist will tell you this. It happens on, I don't care what the liquid is or the gas. As it's cold, it absorbs the gas. As it warms, it gives it off. And as the oceans warm up, they give off the CO2. This is you've all seen this plot probably, of all the different, well maybe not. This is the plot of all the 70 this time since there's 101 now, 73 different models paid by the IPCC of people doing global warming. Now, there are a couple of problems with these. Number one, they don't use a logarithmic curve of CO2. They use a modified linear or logarithmic curve. So they're not getting used using real data. And they also try to throw in a little water. That happens. Water is one thing we, as a meteorologist, we have almost no hope of doing it. That's why your forecast is so great from a meteorologist. It's the biggest problem. But Spencer looked at real data. He says, what's the data for temperature of the mid-level clouds from the balloon data and the satellite data? Measuring temperature. Two different ways of measuring temperature. And sure enough, they overlay. They give the same temperature. And they're not increasing. But this is the real problem of it. The greenhouse theory violates the second law of thermodynamics. What do I mean by that? How many of you put a cup of water in the freezer to make tea? Anybody? You do? Oh, come on. No. Because the second law of thermodynamics points out the fact that thermal energy goes from high to low. There's no place that the atmosphere is warmer than the surface of the Earth. So the Earth gets warm, and the warm air goes up and cools. No matter what's in that air, it's never warmer than the Earth. It's basically, greenhouse warms up the simple fact it's an enclosed environment. I can start a fire in here and chase every one of you out here. But if I open the doors and turn the air on, it just stays cool. That's what greenhouse does. It's not the light coming in. And now, let's jump about. Where's CO2 come from? Now, this is a plot of the last half a million years of temperature, this little blue line, and CO2. And you notice there's not really much of a correlation in there. But what happens to CO2 here? Well, 3.5 billion years ago, nice little things evolved in the ocean, prokaryotes and then the eukaryotes. And then they got together and started to create some things to stick themselves together. And a few of them actually generated some chloroplasts where they could start producing algae. But then, last year, 560 million years ago, we see the Cambrian explosion. And what's that mean? We start to see shelling animals. Animals taking CO2 and calcium and putting it together and making a shell. And when they die, that CO2 doesn't go back to the atmosphere. It goes down to the bottom of the ocean. And we start sucking the CO2 out of the atmosphere. And you see it dropping, until now in the Devonian we had a second hit. Plants evolved. And they produce cellulose. And nothing but cellulose. So it's buried in the floor of the ocean, in the soil, and forms the coal beds, massive coal beds. Luckily, right in here in the Permian, a fungus evolves that generates an enzyme that will digest cellulose. And then a wood roach picks it up, becomes a termite. And we start to see the CO2 come back in the atmosphere. And we start adding CO2 back. Come up here in the mid-Jurassic, and now all those little single-celled animals in the ocean figure out a way to put a little calcium carbonate shell around themselves. And they form the cochlophores and the phytoplankton. Very important for oxygen, by the way. And we see the CO2 drop. And you put a nice little line to that. As Patrick Moore points out, 2 million years from now, we have no CO2 in the atmosphere. We are a organic, carbon-based environment. Life, all life on this planet's carbon-based. It comes from CO2. Now, most of us will be alive by then, so we don't have to worry about it. We'll be dead. According to North CO2, of course, we'll be dead before that, but don't worry about her. This is a standard picture you see in all biological texts, most of the texts. Plants are using CO2. That's true. No question about it. And they take the carbon dioxide in with water and produce wood, cellulose, and oxygen. Now, there's a few people that know this better than most of the people in this room. Marijuana growers. They want 2,000 parts per million there with greenhouse. Not just marijuana growers, tulip growers, and anybody has a commercial greenhouse. I'm not that rich. I don't have a certain CO2 producer. They want CO2 producer. And this is what CO2 does for you. You can double the growth of the plant by just doubling the amount of CO2. Now, as I said, they want 2,000 parts per million instead of 1,000 because it gives you triple growth, cuts the use of water by half, and a healthier plant. So we need a lot more CO2. So please go outside, burn a few things, start a fire, do something. We need CO2. So, exactly where and exactly you can't see me the back of my computer. When exactly in Earth's history did climate not change? You look at geologic history, climate's always changing. Sun drives global warming. If you remember that first diagram, the sun's the major one at the top driving it all. And the global cooling. We'll talk about that. We'll look at three different factors here in the past in geologic history. 2 million years to present, because it's still going on. 13,000 years to present, because that still factor is still there. And down to the last few years, and the probable future. So 2 million years to present. The Milankovitch cycles. Milton Milankovitch worked out the fact that the Earth rotates the sun from an ellipse to a circle and back to an ellipse over 100,000 years, give or take a few. We're now starting, thanks to physics, we're starting to work out astrophysics. We're starting to work out why. He also then worked out the fact that the pole tilts from 23.5 to 20 and back over 42,000 years. And then, last but not least, the axis wobbles around like a top over 19,000, 21 thousands years. You put all three of those together, and you get 90,000 years approximately of cold and 10,000 years of warmth. Luckily, we've been 13,000. In geology, there's been 20 of them in the last 2 million years, and we call that cold period the Quaternary, the Pleistocene, and the Holocene is that 13,000 years of warmth we're in right now. So let's talk about that 13,000 years and what we can see from what we can see from data. Well, what we see is the solar cycles. Global warming, global warming, global warming. The Holocene maximums, the Minoan, the Roman. Got to remember here, Caesar wasn't driving his Ferrari around Rome to create CO2. So there's something else doing the CO2 here. The medieval warm period and the modern warm period. But notice something. Notice this dotted line. At no time is the warmer period warmer than the past warmer period. We're getting colder, unfortunately. This is a fresco from 6,000 years ago in Algeria. That's that Holocene maximum. Large herds of animals in the Sahara. We don't have them anymore, but back then they did. I don't think we were dreaming when they put those frescoes together. And if we go out to the Greenland ice core, we see the same thing. The Minoan warm period, Roman warm period, medieval warm period, and a modern warm period. But again, we see the same thing. Temperatures dropping. And if we look at proxy data from the medieval warm period, the Ice Age, and the modern warm period, we see the same thing. During the medieval warm period, we find mostly the sun's some high, really hot spots, and some generally warm period. And historical data tells us that's a very benevolent period. Then we start to get a little jumpy here in about 1300, and then finally in 1400 we drop into the bottom. And it hits the fan. All during the little ice age. And then we come back out of that in a period that's, we're settling the United States in certain areas. In this period, where it's back and forth. And then we get into the modern warm period. And we're going the other way right now. So we're talking about the weather, the last few years and the probable future. Volcanoes and other factors. Number one, this is the sun, March 2000. Nice hot spots. All kinds of solar sunspots, throwing out tremendous amount of heat. This is back in the warm period. March 2009, first day we start to see no sunspots. Last year we had 21 days of no sunspots last year. The year before, 2017, we had around 100. 2016, 50. We're getting more and more sunspots. The sunspot total as of yesterday was 53 since January 1. That's well over 60% of no sunspots. Part of the reason we've had the weird weather we're having. The interesting thing, this was done in 2011. Some forecast data. Looking at the drop in going from sunspots to no sunspots, the total solar irradiance, basically we get about 1,366 watts per square meter from the sun, on an average worldwide. And they were looking to say, okay, it should drop here to about 2040, drop to about 1360. The measurement yesterday was 1360.05. We're way ahead of schedule for this temperature growth. This is part of that what we didn't know. So we got to come up with a little bit of more. This is another one of those what we didn't know. Zarkova, Valena Zarkova, was looking at some mathematics to plot magma fluxes. The best set of magma flux she could find was the shallow and deep flux of magma in the sun. So she threw it into the equation, and what fell out? Middle warm period, little ice age, and the modern warm period, and then some other future stuff. And it's been checked by half a dozen people and found that the mathematics are right, unfortunately. Because if you blow it out, when the fluxes are in sync, we have warmth. When they go out of sync, then we get wild weather. And basically what she's saying here is, as we go forward, this winter was twice as bad as last winter. And the last winter was twice as bad as the winter before. And sure enough, guess what we had? We had 3 major blizzards this year. Last year we had 2 major blizzards. The year before that, 1. And before that, 1 or 2 would show up every 10 years. So now we're going from benign warm period with variations to constant variation. What's that sun do for us? Well, when it's a nice high solar activity, we have a strong solar magnetic field. And that shields the Earth from cosmic rays. We have a warm Earth. When we have a low sun solar activity, we have a weak magnetic field, and that gets more cosmic rays coming in. Now we can measure that. If you go to the northern states, Washington and Maine, it's a 19% increase in cosmic rays. If you go to California, it's a 13%. Now why the difference latitudinally for the amount of cosmic rays, I don't know. And this college won't give you the money to go find out. Don't worry about it. Somebody else will have to do it. But what do cosmic rays do for us? They do 2 things. One, they penetrate into the mid-level clouds and increase the cloud nucleation particles. Now what's that mean? That means instead of getting a mist, you get a downpour, a waterfall. The rain bombs, people getting floods, i.e. what we got up north in northern states right now. Major, last January, into January, Bavaria gets normally 8 foot of snow a year. They got 16 feet in 10 days, and they got more coming. Middle of summer last year, we had 2 foot of hail flowing down the streets in Rome. We got some cities in can't think of the Arabic country. One of the little Arabic countries got a year's worth of rain in 2 hours. We had lost 800,000 head of cattle in northern Australia in 2 weeks of rain. We're getting that type of rain situation, and we'll get more of it. And the other thing, which is a real problem tectonically, is the muons penetrate the surface of the Earth 2,000 meters, and activate the magma chambers. Now, it hasn't affected us. We don't have a volcano here. But last year, 2017, we had 147 active volcanoes. 20 years ago, we had 10. Now, as I said, we'll talk about one of them that could affect us. But now, let's look at 5,000 years of what here. Let's look at these cold spots. The more cold spots, the more volcanoes. The deeper the cold, the more volcanoes. But Mother Nature was very nice. They did an experiment for us. We got this one period with this little slice in here. That's Pinatubo. Now, most of you can remember Pinatubo. It blew up in the Philippines, at the equator. It put in 6,000 up into the stratosphere for 6 days, CO2 and SiO2, or SO2. CO2, benign. SO2, was mixed with water, forms sulfuric acid. And what's that do for us? Well, sulfuric acid acts like a bunch of little mirrors. And this is what it looked like from the space station. Blocked all that sunlight coming in from the sun at the equator. And that's where we get most of our heat. And it dropped the temperature of the Earth 1 degree. As long as we got one or two occasional volcanoes, we had Mann blow up, what was that, in February? They only did it for 5 days, and only 3 of them were towards the stratosphere. So that didn't do too much. We get 4 or 5 volcanoes going, and we got a problem. Now, tectonically, a lot of this was worked out by a gentleman named Casey. The reference is on the back of that sheet I passed out. West Coast, let's put it this way, that'll be economically a problem if it's on the other side of the West Coast, but it's not going to affect us personally. Might affect our pocketbook, but we're not, be okay. That's on the West Coast. And what are we seeing? Very simply. In November last year, in one day, the San Andreas Fault had 36 earthquakes. Now, they were minor ones, but still, it was acting. It was going back and forth, just like a zipper. You look up in Alaska, they've had dozens of earthquakes up there and volcano activity going on. And they're even talking about the Mount St. Adams acting up and a number of other volcanoes. And one new one that they didn't even think about in California. It's coming up. The one we have to worry about is this one right here. And it's even showing up in our news media, which is surprising. But it's acting up. If it blows like it has in the past, it will put ash all the way from southern Canada to Waco and from the Rockies to the Appalachians. Bye-bye. That's the food supplies for the world. Because it'll take us at least 5 or 6 years before we can start thinking of planting something going towards the edge. The real problem, not so much for us because we're out of it, is the Lubitsch earthquake, Mississippi Valley. This is what it looked like, the activity on the Lubitsch earthquake, 16 benign, 1800 benign, 1812, we had the one we know about, another benign times. But back in the Lubitsch Wander minimum, major shake there. And what we see, if we have another one like that, it will be very, very simple. It will take out every 8 states' power plants up and down the Mississippi. To replace those power plants will take 2 to 3 years. They will have no electricity. It will also take out 7 major freeway bridges and numerous other non-freeway road bridges. So the east will be cut off from the west side of the Mississippi. Also 5 major railways. Bridges will go down. And 17 oil and gas pipelines going to the northeast. Thankfully, you're living in Texas. Let's put it that way. It will shake us up. We'll lose our power grid for a week or 2. Then we'll get it back up running. And we have food over here. They're going to have a real problem. Savannah, Georgia, we've had a record of earthquakes, and it's knocked some buildings down. Nothing too bad. Puerto Rico almost got wiped out. The end of the little ice age was just settling. What will happen now is a good question. But the real problem for the East Coast is on this one. We've known it for a number of times. We've tried to ignore it. La Paloma volcano in the Canary Islands off the west coast of Africa has had a couple of shakes. If it cuts loose, it's ready to dump a slide of 589 million tons of rock into the Atlantic Ocean. 6 hours later, 100 foot of water hits the East Coast, from Brazil up to Nova Scotia. And everything on the coast for 15 miles in is flat. Major, major hit. We'll be okay. So now, but the real problem worldwide is, oops, went the wrong way, James, is food. Cold weather, or I should say grand solar minimum, crop losses. Not just cold weather. The whole disruption of the weather pattern. As a farmer, you're gambling on what type of weather you're going to have to plant the crop. Am I going to get in soon enough? By the way, is a 2-degree drop in temperature a problem? Not consistently, just say the average temperature for the year is 2 degrees colder. Is that a problem? You're not, you've been a farmer. Anybody been a farmer? Nobody has. That means spring comes 2 weeks later, fall comes 2 weeks earlier, and we don't grow grain north of Oklahoma. Also in Europe, most of other countries that grow grain. And nothing personal. Most of you eat some wheat, don't you? And some corn. We got a real problem if it happens. So, 2000, 2002, the green countries are the countries that export more food than they eat. They import to eat. Canada, U.S., France, Bulgaria, Ukraine, Thailand, Australia, Argentina, and Belize. Last year, Canada and Ukraine are the major exporters of potatoes worldwide. They had a wet spring, short, dry summer, early wet fall, and the potatoes they were starting to harvest were about half size and not quite ripe. So they were starting to lose a lot of them in the storage bins. And then the last half of the crop froze in the ground. They lost it. It's gone to the point now that in Egypt they're putting guards on the warehouses to keep people from stealing potatoes. Australia will ship no wheat. Between frost and drought, they didn't produce it. They're one of the major producers of wheat. Thailand doesn't ship rice particularly, but they will not ship they're not a large shipper of rice or producer, but they will ship no rice this year because they won't have enough rice to feed their people. Now that's the equator. That's not up in the northern parts of the southern part. That's the equator. They're not getting the problem. Argentina has seen a reduction. Belize, we don't think much from Belize. They know the price of lemons and limes. Any of you? Lemons are double, limes are triple in price. Your food prices are going up. And Canada's had some problems, so have we. So, this is the amount of wheat shipped over the last 4 years. And you notice it's been increasing. And this year we're shipping 55 million metric tons less wheat worldwide. Number one, Australia's not shipping any. Argentina's a little less. Brazil's maybe a little bit more. And you can see what there. The basic thing is we're losing 55 million tons. And that's what's feeding the world. Because most of the world, as you go back to that first one, isn't feeding themselves. They're being fed by the green countries, the ones that were green in that picture. This is a little plot of archaeological data of the Indians planting corn. During the medieval warm period, they were clear up here in northern Wisconsin and up here across the lake into Michigan. Coming a little ice age, they were driven clear down to the southern Michigan and southern Wisconsin, 320 kilometers south. What's that going to do to a couple people north? Now, wheat is a little bit more tolerant of temperature than corn. And Alberta, Canada grows wheat. And right now, as the warm climate we have, they've been growing up in Alberta, Eau Claire. This is basically where they've been growing it. You drop the temperature 1 degree, they go to the blue. Drop it 2 degrees, they go to the dark blue. And that's where they were in the mid-1800s, when they start producing crops in wheat in Canada, and they were losing basically a third to a fifth of their years of crops. So it'd be good for 3 out of 10, 5 out of 10. They'd get crops. The rest of the time they wouldn't. And then they started using some Russian red, they got a little bit better. And then it started warming up and they started being able to produce other places. We are a corn producer in the United States. Warm climate is produced out of Iowa. You've heard that. You drive it 320 kilometers south, we go to Arkansas. Less stable to corn. We lose 40% of our corn crop. Because the soil's not good for corn, and so is the climate not. The weather pattern, the rain pattern. And this one is a scary one. I've run across this. This is not just weather and climate. This is crop rotation and other factors mixed in. But weather's part of it. But you go back 10 years, there was no negatives. It was all positive. This year, every place is growing less production. And we will lose 20% of our production, average, in the United States. Future, this is, we're going to go back to a little ice age, basically, Neoboreal area, for 20, 30 years. Food production will be dropped, increase price of food, and famine disasters, and famine migrations. We know that right now. 30 years ago, there was plenty of water and a warmer climate in the Near East. They grew a lot of grain, had a lot of babies, and now those 20 and 30-year-old men got to go someplace. They're going to Europe. We yell about other things, but the real thing is they want to get fed. I don't blame them. I would too. I like eating. But there will be some good things. Energy go up in prices. We produce our own energy, won't hurt too much. But you've noticed the price. What's the price of gas today? Yeah. I remember not too long ago I was buying it less than $2. In fact, I was listening to a truck driver. It was because of the problems of all the bridges out and stuff up in Kansas and Nebraska. It's taking him a day or two later to drop stuff off, and much higher gas prices to drive. He's losing money. And that's going to have to translate into higher pay for him, which will translate into higher price for food. But it'll be good for people who like to ice skate and snowboard, and people working in the auto industry repairing autos for auto accidents. I don't do that, unfortunately. But this is a problem for every one of you to consider. Transportation in the past of the Little Ice Age and modern. The pros and cons. That's not my bailiwick, that's all yours, depending on what you're doing. The modern dependence on energy other than wood. How many of you got a fireplace? And access to a firewood, forest or something around you go chop. I got a fireplace, but nothing, I can go chop a couple trees down, but that ain't gonna last me for a month or a week. Think about that. If the power goes out, What are you going to do? Crops bred for warmer climates. Luckily, in one respect, the heritage vegetables and crops do better in a varied climate. But they're not that pretty, beautiful, ripe red tomato or apple. They're all ugly looking, varied colors. Taste may not be as sweet, but they're still edible. Total dependence on populations. I'll give every one of you a challenge. I haven't had anybody accept it yet. Go home Friday night. Give your car keys and your cell phone to a friend. Turn off the gas, electric, and water. And if you have not committed suicide by Sunday night, you can turn it back on so you don't smell bad when you come to school next morning. And you laugh at me. But 100 years ago, 50% of the people in the United States lived that way. And today, at least 90% of the people in the world live that way. Without clean water, electricity, or some sort of heat other than chopping a piece of wood. And the last one is, depends on just-in-time deliveries. Now, how many of you know what JIT means? Now, you don't count. He's a geologist with me. He's been watching this stuff too. Just in time. What's that mean? That means when you go to the grocery store or the drugstore and you buy something, they type that in, and that number goes in and goes to the warehouse and says, oh, they're down to a few tubes of toothpaste. We need to send them a pallet of toothpaste. And the warehouse clicks that off, and instead of having a dozen pallets, they're down to 1 or 2 pallets. That sends them an electronic message to the manufacturer. They need toothpaste. Make a bunch of pallets and ship it to them. When the electricity goes down, another carrying effect, your cell phone doesn't work. Cash register doesn't work. None of that works. Grocery stores and pharmacies and drugstores have 3 days of supply, period. Anything to disrupt that. Bridge goes out, train gets stuck in the snow. The real answer is going to be a couple questions. Change the climate or adapt. Change the climate. That right now is the purveyor of the coastal elites and the globalists. They're already donating a couple of $1 million a year money to Harvard to study how to spread some fine aluminum ash, not aluminum foil, particles up in the atmosphere to block sunlight. This is going the wrong way, but that's what they're doing because they believe in that. Or we can adapt. We can do what we've done for the last 400,000 years, evolution of humans. The individual mind doing something to keep their ass alive. And that means that some people aren't going to make the wrong decisions. Some people make the right decisions. But as long as we don't let one person make the decisions for all of us, we're probably going to be all right. Unfortunately, considering the situation in the world today, or at least in this country politically, I think I have to agree with this guy. We ain't got much hope. In fact, there's one thing that's interesting about this guy. One of the ladies that was a member of the Church of Global Warming of Al Gore just published a report that there are over 40,000 polar bears today. Why? Simple. Doesn't have a damn thing to do with climate. What do polar bears eat? Seals. We no longer kill seals. So they got more food, which is a good idea. So now, jump into the climate, the politics. It's become a blood sport because they don't know what they're talking about. If you're a scientist, you follow the scientific method. You formulate a hypothesis, you collect the data that applies to that hypothesis, and you modify the hypothesis to fit the data. If you do the climate science method, you formulate a conclusion, just the opposite. Modify the data and the conclusion to get what you want, and then tell the world it isn't ending. As one famous gentleman, Al Gore, said, there will be no more snow in Washington, D.C., and our children will not know what snow is. He hasn't offered an apology yet, but he's made his millions, so what could say? He's a great scam artist. They're also the one that's, interestingly, they just announced that the Greenland Glacier, the glacier that was on the east side of Greenland, they've been screaming about, has grown 8%. It hasn't lost weight, it's grown 8%. It's going the other way. And they produced this diagram, which is drastically different to the diagram I showed you the first part. The question is, where did it come from? United Nations probably started it more than anybody else. It was a simple fact. They, when they created the IPCC, gave them the mandate to come up with why man has caused global warming. Not why global warming exists or what it caused it, but why did man do it? And they lied a bunch. We've seen that in other reports. Falsified data, came up with stuff like that. But a few years ago, they started to jump the shark with the Paris Accords. Compliments of Obama and Kerry, we are part of that. The unfortunate part of it, you read the fine print, we cannot get out of it for 4 years. We can say we want to get out of it, but we're stuck for 4 years. That's number one. The number two part of the fine print is we will be paying trillions of dollars for 300 years of CO2 in the atmosphere. Now, I don't know, most of you probably have enough history to remember that we were just settling this country 300 years ago. We were a couple little isolated towns on the Atlantic coast, and we were burning wood. We weren't creating much CO2, but we're going to pay for it because they want that money. News media, the media used to be what, where, and when, and you figure out the why. Now they tell you the why. It's global warming or somebody they hate. It's that simple. I don't know, someplace in there there'll be that. And that switches over to the politicians. Politicians, squeaky wheel gets grease. That's what they hear. So there's be interesting in that. Now the one that upsets me more than anything else is the environmental groups. There are very valid environmental problems that need to be solved, instead of wasting the time on CO2 and some other things. There's truly valid problems for life. And the unfortunate thing, they've wasted most of that, what do we call it, credit, in creating different groups in the state capitals, local cities, of CO2 advocates. Not doing anything for everybody to grow. Capitalism is great for moving the poor up to the middle class, give them a job. But capitalists, they're the good, bad, and ugly. They're individuals, like anybody else. What do I mean by that? Well, the ugly. Solyndra. How many of you remember Solyndra? Yeah. $500 million from Obama's EPA to make solar cells. Blow $300, blow it, 3 years later file bankruptcy. And keep the money, their six, seven figure incomes, and bye-bye. You and I are still paying for that. The bad, GE. They have budgeted $40 million this year for lobbyists. Why? Because they can go to China, have China build the core of the wind turbines. And then you get a nice grant to help them pay for that to China. Transport to the United States and get another grant to cut the deal for the tariffs and the transport. Sell it to a company they're part owner of, and get a cut there. And then put those wind turbines up, and then get a nice big grant to make so they can sell that power from the wind turbine at the same rate they're selling the gas and oil, and gas and coal. Gas. But the really one that upsets me more than anything else is then they get a special dispensation to kill thousands of eagles and millions of birds. You and I would go to jail for one. But they're just, that's okay. It's green energy. We can figure other ways to do that that are more beneficial. And then the last group, which I did, right, is the scientists with no ethics. Michael Mann's famous hockey stick, the red bar. It goes on there and it shows them right there, no global warming until modern times. And I got one special guy for you historians. Why didn't you get the pitchforks and go out and virtually burn this guy at the stake? You know there's been a medieval warm period. We got the history for it. We got the paintings. We got the writings for it. And in the Little Ice Age, we've even got temperature data for the same thing. And thankfully, he was finally forced to reduce his data, and a month after that, it was proved totally false. But they're still talking about it. So, future reading, you've all got that. I just picked up an interesting book. I'm about halfway through it. One of the ones you've got in that list is Fagin's book on the Ice Age. This one's called Nature's Mutiny by Philip Blom. He's a German. It's translated in English, thank heavens, because I can't read German. And it's interesting, his aspect on the Little Ice Age versus an American's aspect on it. And he brings in some different points. But basically the problem is when you can't feed yourself, culture has to change. And we see that change. Any questions, comments, or otherwise? Let me put it this way. I've hit the high points, the, what do we call it, the short periods, but would love to come down and sit down and explain anything, questions and details with you at any time. Because every one of these needs to be expanded.
You raised quite
I raised a lot, yes,
interesting statistics that could be debunked in so many different ways, to put lightly. I believe we can have this conversation going where we have somebody from the your point of view and an opposing point of view, and then of course examine the whole data. The data you showed about the professor from Ukraine, I forgot her name, what's her name, Zakharov? Yes. Yeah, okay. The ice age and modern time, there are a lot of things wrong with those statistics because we did not put into consideration the population, okay? Oh. We did not put into consideration...
No, she's looking at the data of the plasma flux, and then what fell out was that.
Exactly, but that data, without factoring in population and the distribution of population and the advancement in technology, there is no way we can actually predict that we are going back or that there's an ice age coming. What we have now is more of a crisis that, and even if we have an ice age coming, that means the population, the global or world population, will be wiped out almost to get to that stage. So,
Yeah, I'm not following what you're saying.
from I'm just basing from
Was
the
he
graph.
saying it's going back? Now, whether it'll be wiped out or not, it's a good question.
Yes, if
That's
we
what
have to,
that's
she's
my
saying that we are
statement
going. She is saying that we are going to the ice age back. You know, she's saying that carbon
Possible.
dioxide is not a factor, that it has always been there, but they not put into consideration so many other factors. You know, but you cannot compare. We cannot compare what happened 1,000 or 2,000 years ago with what we have right now.
We can look at what is happening for the sun, and the sun drives it, period. We are the pimple on, we're not even pimple, we're bacteria on the elephant's ass, let's face it. Humankind's are nothing compared to the world. We're the only thing that works linearly. Everything else in the world is cyclic. And that's the problem there. I know where you're coming from in that respect, and that's the problem. We don't, and that may be the fact that from the geologic standpoint, we've always seen this. And mankind wasn't even around when we saw it in the past. Something else was driving it. And the question is, what's driving it is the sun. And other factors fall in, but man is not has those factors. That's the problem there.
Because I have followed closely that professor's hypothesis over the years.
Now she's just, what, Zarkova?
Yeah.
She's fairly new.
No, she's been around. Okay.
Other things.
Yeah,
but-
on other things, you know, and she has been coming up with this hypothesis about climate change and where we are going with it for quite some time. And I've followed her career very closely in that area. But anyways, it's a very complex and complicated
Yes, it's definitely
discussion.
complicated.
Let me hand this over to somebody else. Dr. Stemalis, you want to take this?
Sure she does.
Thank you. So Mr. Mellott and I have talked about this very subject several times in the past before. And on some of the things, I will absolutely agree with you. My background, my doctorate is in environmental science. And I agree, there are cyclical fluctuations, like you mentioned, the Milankovitch cycles and the fluctuation in sunspots. All of those things absolutely impact the climate and cause it to fluctuate and change over time. But what we have seen with, I would, almost, use the word undeniable evidence that we have with many scientists with, 95 to 97%.
You know where that
certainty.
comes from?
Sure.
Do
Go
you?
ahead. Do I know where that
You know where that
evidence
term comes from, that 97%? That is the biggest fake news around. That was a comedian looked at data, and it had that term in it. That was a person who agreed with it.
That was also stated in the IPCC.
I know it's
report
a,
that
and they lied
not a
right and left.
comedian, but hundreds, if not thousands, of scientists from varying fields across the world, from biology to physics to chemistry to geology, that we're seeing anthropogenic effects on top of the cyclical changes that are leading to our fluctuations that we're seeing today.
What do you mean
So,
by anthropogenic effects?
human-caused effects.
Okay, in respect of the
Carbon
increase in CO2?
dioxide, and
Yes.
that there are cooling trends, definitely, by sulfate aerosols from airplanes, from volcanoes, all of those things. But above and beyond that, we're seeing the warming of the climate. So
Yeah, and the
I
Greenland
agree
climate.
that if we had an opportunity to show the contrasting side of you,
I looked at the contrasting, that's what I'm saying. First of all, consensus is not science. Science is fact. 73,000 people.
I take personal affront to when you showed the graphic on how climate science has been with the scientific method, manipulating data to show a conclusion.
I didn't say you.
Personal affront.
I said, but that's the general problem, is what's happening. We see that thing. And I have a problem with it, personal problem with it. I have a personal problem because show me the scientific method. What they've been using there's no time it fits the scientific method.
Takes that into account.
Yeah, the problem is in one of the ones that was brought up to me in the past was the glaciers are melting. The three major glaciers are where? Antarctica, the Arctic, and Greenland. No question. Antarctica is melting. There's 7 volcanoes under it. You put an ice cube on the stove, turn the heat on, and it melts. It's not melting to the top. They're getting 6 foot of snow a year, wiping out the solar observatory you put in down there, and having to raise the stations down there because they're getting buried. Arctic's 50 feet of ice on water. Every so often, that warm current is pumped onto there, and it melts from the bottom. Doesn't melt from the top. It melts in the summer occasionally, little bits of it, and freezes again in the winter. And the Arctic mass has been growing. They've been looking at that. You almost have to go to the Norwegians. They seem to be the less polluted data.
Yeah, I've always heard the Arctic ice sheets melting, and ships are now relatively easily going through the Arctic at this point.
This year they
Tundra is
couldn't.
melting.
They've been having to fly in supplies to Hudson Bay area because the ships going in there at the end of this fall were blocked by ice, and they didn't have enough food to survive for the winter. And
But is
had
that
been-
consistently year after year?
That's what I'm saying. It's growing. I'm not saying it's been there for 10 years. I'm saying this is what we're seeing, the change in climate. Climate doesn't go, in fact, we'll maybe go to a short warm phase next year. Or we may have a foot of snow or two foot of snow down here next week. That's weather. That's that complicated thing, what all factors we don't know happen together. But what I say is climate is the average over hundreds to 300 years. And we're seeing the change, and we're going into some facts, the astrological facts, astronomy, that we see that definitely fits the previous period.
So why are the climatologists wrong?
Not all of them are, very few of them are. And you go to regular climatologists, Tim talks, I think Tim Ball, there's a couple of them I listed there. They were regular climatologists. And fact is, and I've hit you up, Castillo. How do I get a hold of Happer?
I'll let you know.
Okay, thank you. William Happer. Now, the biggest gripe about him, he's a physicist, not a climatologist.
Oh, yeah, he's on DARPA, the Defense Advanced Research Project Agency.
Yeah. And he's, what I would say is an individual with a very open mind. He looks for facts, not consensus, not what everybody else says. He wants to know that and this is the problem with it. You're right on this respect, by the way. This is the fact of the problem with it. You've got to go down deep, 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 deep to the basis. Serious and natural gas. Yes.
What happens if you're wrong? That is, you've
Now, wait a second. We can grow a hell of a lot more crops in Southern California than we can in Alaska. I love global warming. I'm a farmer.
Okay, but what happens if you are, and your climate change, skeptics are incorrect?
Nothing.
And we do
We've
nothing.
already had a 4-degree increase in temperature. We've already had 4-degree temperature.
The reason I'm asking this is there seems to be at a minimum here.
Good shot.
He's got a PhD in science.
Go ahead and continue.
I'm going to assume that that's not in physics.
No, she's agreeing with you.
I'm wondering why, you've suggested effectively that the American Medical Association, NASA, the American
Now,
Chemical
wait a
Society
second.
are all lying. Hang on, I'm not done. Are all lying, okay?
No,
That
I
we've
didn't
all
say
been,
lying.
we've been tricked into believing that this is a thing. 97%, 60%, whatever it is. What I'm not hearing from you is any balance to this that says if I'm wrong, and this is human-driven, and climate change does change to the point that it begins to affect quality of life
Well, as I
across
said,
the globe. If that occurs, A, is it reversible? And B, and more importantly, from a policy standpoint for governments, why not just take Pascal's wager here? Go ahead and make changes. If the globe doesn't warm up, no harm, no foul.
Well, two things on that. Number one, who uses CO2? Biologists?
Autotrophs, things that photosynthesize.
Thank you. Plants! Why, God damn it, we need food.
Do we have more of those than we do today than we had in the past?
Yeah.
Trees?
Yeah.
We do not.
Why? Why?
They just cut down a whole bunch in the freeway.
Yeah, why do we have more trees? We quit cutting them down. Why are the polar bears growing? We quit killing the baby seals. They got more food. One of the things I should have pulled out here is the fact that you can look at, and from the satellites, thank heavens, you can see the fact that we've seen a significant greening of Earth. And the more greening, that means there's more food to eat. And that's part of your answer is, hey, we've had periods in the past history, geologic history, of far greater warmth. More people die of cold than they do of warmth. Now, I admit, I like my AC, but I can live with I can have a siesta in hot times. But I can't have a siesta in the middle of 20 degrees temperature. I freeze. Yes, ma'am.
So I'm the eternal optimist, and kind of along the same lines with where he was going, what does it hurt if we do try to mitigate any changes that we might
How you gonna
be
mitigate
making?
them?
By decreasing our consumption of fossil fuels. What does that harm?
Well, there's a couple, this
Because
is a whole different
there's
subject,
not a
but
question
you got a
of
good
if we'll
point.
run out.
Because sometime we're gonna run out of coal, oil, and gas.
Correct.
So we gotta figure out how to do something about it.
Right.
But not on my money. Now, if you wanna pay for it, that's fine. But I got
In
other things I
my
gotta pay for.
child's lifetime and
Grandchildren,
in my
children.
grandchildren's,
I know, I gotta pay
that's
for
a
them
very
too.
real concern.
So you wanna steal from me to do what you want.
The beauty of the American system is that you have an opportunity to decide how your tax money is spent by casting your vote.
You go back far enough in history, it wasn't tax money.
But you're part of a social contract where we have all agreed that if this is what we decide we're gonna spend our money on, this is what we're spending our money on.
What's
I
the
would
social
think not.
contract?
The US Constitution.
No. The social contract goes back to a deal you and I make between us. Then we've generated from that onto the Constitution and other things.
Well,
But the Constitution doesn't say taxes are there.
I'm gonna stand pretty firm on my position on the fact that the Constitution is a social contract.
I can use that, that's a slight term, go ahead.
I'm almost for Laurie. Are you gonna hit me with that thing, Laurie?
I haven't said anything yet.
Yeah, but you got the thing to throw. That's what's frightening me.
Yeah,
A couple of things I'd like to address. The gentleman up here, couple of things. He points out that if we do nothing, if we do nothing, we'll just continue like we are, and it'll get cooler. If we continue, if the world does get warmer, if he's wrong and the world gets warmer, we can just grow crops farther north and feed more people. A warmer world tends to be a wetter world. If you look back at the Cretaceous or before the big extinction event in, well, you can talk like a geologist now, but if you look back at the Cretaceous, there was 10 times as much carbon dioxide that you have in the world now. It's like 3,900 parts per million. And the world was warm and wet, and we had giant herds of huge animals. There's no way a warmer world is going to be a drier world, because you evaporate more water from the oceans, it's got to go somewhere. And someone else pointed out something, oh, I should have wrote this all down. But, you know, what right now is the Green New Deal that's floating around is going to cost $90 trillion. Who has $90 trillion laying around? I can go with $90 trillion something looks like. I can see no logic in destroying our economy and putting everybody out of work. Yeah, I like to drink clean water and breathe clean air as much as the next one.
I don't trust air I can't see.
Well, you can't see CO2. You can't see oxygen.
No, I do think, but, we all want a good, clean environment. But I've lived without electricity. I've lived without indoor plumbing. It gets real rough on January night to go out to the outhouse about midnight or 1 a.m. Trust me on that one.
I've done it too.
I'm done, and drawing water and cleaning that cotton picking lantern. I don't want to go back to living like that. Now, I don't see where it's going to destroy our grandchildren. And to be honest with you, what you said about, are the climate scientists wrong? I could show you a diagram with about 70 or 80 of their climate predictions. Most of the climate scientists are really computer geeks. But observationalists, balloon data and satellite data does not show the warming at all, zero, period. I can provide that to you if you like.
That's one of the slides I showed.
Oh, it is?
Yeah.
You stole it.
Hell yes. You think I want to, if they don't pay me to create stuff, I might as well get it someplace else. Not this campus. Lori, pay raise, please.
Oh, is it my turn?
No, I'm just saying pay raise. So I can do research.
I think a lot of us are missing the big picture here. Scientists are going to squabble over details until they die.
Yes?
It doesn't really matter if it gets warmer or if it gets colder. What really matters is that you make an environment that is habitable and livable for people today and in the future. It doesn't hurt anybody to recycle a can. It doesn't hurt anyone to go electric. It doesn't hurt anyone to use wind power. So the big, bad doomsday thing, in my eye, is irrelevant. And I probably am contradicting
No,
you
you're
on
not.
some of that.
I'm an environmentalist, believe it or
But
not.
I think for population-wise and locally, a lot more people can make a lot more progress just by taking care of things and being considerate of other people.
Yeah.
And reinventing.
And what?
Reinventing.
Reinventing. So that's all.
Yeah. Good point. Okay.
Thank you for that exciting discussion, and
Yeah.
see you next month.